Hi everybody, I am Sandeep Gupta and this is lecture number 2 of C programming series. In this lecture we are studying fundamentals of computer programming. The first topic which we are studying today is Introduction to C, and in this topic we will be studying a very simple C program. So this is our first C program where we will be studying some introductory features of the C programming language. What you see in black color over here is a C program. This statement, which starts with slash star and ends with star slash, is called a comment. So that way you will see 3 comments in this program. Now what exactly a comment is? A comment is a statement which is not a part of the main logic. A comment is actually written for the reader of the program so that he reads the comments and understands the program easily. Now this program is quite small and simple, but in future you will definitely write programs which are much more complicated than this one. If a program is very difficult, then the comments in that program will help the reader to understand the logic of the program easily. Please keep one thing in mind, a comment is not written in C language, it is written in English language. And that's why comments are straight away ignored by the compiler. The compiler does not convert a comment to machine language. One more simple thing which you should understand is that if you see this comment, it starts over here and it ends over here. So anything which you write over here on this line here will also be treated as a comment. Okay. Now once you understand what a comment is, let's go to the next statement. Any statement starting with a hash is called preprocessor directive. I repeat, preprocessor directive. Why exactly we write this statement and what work it does, that I'll tell you in detail in the upcoming topic of the same lecture. Right now, just remember one thing. This stdio.h is the name of a file, where stdio is the first name, h is its extension. Stdio stands for standard input output, h stands for header. So stdio.h is a header file. Moving on, we come across void main. This is the starting point of the C program, and here the execution of the program starts. Some people write int main, some people write only main, but I prefer writing void main. Now why we should write void, why int and all, that we will be studying in the chapter of functions. This is just an introduction. Now after void main you will always put a pair of parentheses, I mean round brackets, and then you will put opening brace and then a closing brace. Whatever work you want to do in your C program will be done within the 2 braces. So within the 2 braces I have written 2 printf statements. Every printf statement will do the work of output. That means it will display something on the monitor. Whatever you write within the double quotes will be displayed as it is. So if you see the output of this program, the first printf will display the output welcome to C, and the second printf will display the output begin with C. Now in the second printf, have a look at this slash n. This slash n is called new line character, and because of the slash n, this output comes on the next line. Also pay attention to this little space over here. Because we gave a space over here, the same space is reflected in the output also over here. So that was the first C program for you. Now once you understand these introductory concepts, what we will do is, now we will practically execute this program and we'll see the output of the program. If you want to do C programming on your computer, then on your computer you need a C compiler. There are various companies and they provide their own version of C compiler, like you have Turbo C++, you have Borland C++, ANSI C++, Dave C++, and so on. The most basic version and the simplest version of C language is the Turbo C++. By the way, if you install Turbo C++ on your computer, you can do C as well as C++. So now let's see how to install Turbo C++ and how to practically do C programming.
Hi. So now let's try and understand how to install Turbo C++ and do C programming on your computer. If you want to install Turbo C++, the first thing you should do is you should check your PC info. So go to the search option of Windows and type over here PC info. Now when you go to PC info, you need to check whether your computer, whether your operating system is 32-bit or 64-bit operating system. If you have Windows 8 or Windows 10, there is no need of checking anything because they are 64-bit operating system. If you have Windows 7, then you need to check this thing. Once you confirm whether it is 32-bit or 64-bit, now let's go ahead with the download of the Turbo C++. Now for that, we'll open Google Chrome and we'll go to our institute website www.study-circle.org. So this is the home page of our website. Go to downloads, go to softwares, and over here you will see two Turbo C++ files. The first one is for Windows 7 32-bit and also for Windows XP, an earlier version of Windows. Another one is for Windows 7 64-bit, Windows 8, and also for Windows 10. Now once you download any one of these two files, you can see it in your downloads folder. Currently I have kept this file over here on my desktop. To install Turbo C++, all you need to do is just double click this, click on next, and the installation will get over. After the installation is over, what you can do is go to the C drive of your computer. In the C drive, you will see a folder called TC, and within TC, you will see a subfolder called bin. This folder is very important because by default, all your programs will be stored in bin. Right now, I'll minimize this. Now to start Turbo C++, you can use the shortcut icon on the desktop. So double click on the shortcut icon and you see a screen like this. Once you see a screen like this, that means Turbo C++ has started. And what you see in front of you, this plain blue screen, it is called text editor of Turbo C++. I repeat, text editor. A text editor is a program which can help you to type text, edit text, save, cut, delete, and all those things. Notepad is the simplest example of a text editor. Now let's do one thing. Let's type the program which you have already seen before. So I start with hash include stdio.h. I'll not write a comments. Void main parenthesis, then printf. Within the double quotes we will write welcome to C. Then one more printf. Within the double quotes we will write /n space begin with C. I'll be adding 3 more statements in this program. Why exactly I'm writing these 3 statements, I'll let you know in a while. So we have get ch. Over here I'll write clr scr, the full form is clear screen, and over here I'll write hash include conio.h. Conio stands for console input output. This console input output hash include conio.h is a supporting statement of CLR SCR. So if you don't write CLR SCR, you don't need to write conio.h. Anyway, now the typing is over. Now let's save the program. But before that, I'll just minimize the screen. So this is the desktop again. This is the bin folder in front of you. And this is the Turbo C++. This is the same program which we have typed just now. Now I'll click on save. When I click on save, have a look at the path over here. You will see that by default the program will be stored in C:\tc bin. If you do not give any name to your program, then by default the name of the program will be noname00.cpp. CPP stands for C++. You don't want your program to be a C++ program, so you change the extension to .c and you give it any name like first.c. Now when I click on OK, I want you to look over here as well. Okay, over here. Now I click on OK. So when I click on OK, you see over here, you will see a file first.c. So what we have done is we have stored the entire program in a file first.c. If you want, I'll open this with Notepad and we can check this with the help of Notepad. So open with Notepad and you will see the same program. Now once the typing is over, once editing is over, we go back to Turbo C++ and now we'll compile the program. So for that, look at this option of compile. I click on compile and again I click over here. Instead of doing this, I can press Alt F9 together and the compilation will start. Again, when I compile the program, have a look over here again. So I click on compile. And when I click on compile, please see over here, there is a file first.obj. What has happened over here is the compiler first went through our program. Because there were no errors in our program, the compiler converted the source code to machine code. This machine language is also called object code, and that is why it is stored in the file first.obj. Now over here, look at this message. It says success, press any key. So I press any key and the compilation is over. Now I click on run and again I click over here. So when I do that, you will see a black colored screen which is called the input output screen. This is the screen where you will get to see the output of the program. So as you see over here, you see welcome to C, the output of the first printf, and begin with C, the output of the second printf. Note over here that you will see some space before begin. That is because we had given a space in printf. If you are done with looking at the output, just press any key. So I press the enter key and we are back at the program screen. Now let's understand the purpose of these three statements: conio.h, CLR_SCR and getCH. Let's try and understand why did we write getCH. So for that, let me remove this getCH. Every time I change the program, I should save the program and I should compile the program. So now I'm compiling the program as Alt F9. Successful, so I press any key. Now let me run the program. So run. Okay. One more time, I'll run the program. I click on run. Again I click on run. Did you see the output? Okay, let's try one more time. I click on run and again I click on run. Did you see the output? Well, I think you did. Now what happens over here is the output actually appears in front of you for a fraction of a second and then it disappears. And because of that, you cannot see the output. So what getch does is it holds the output screen in front of you so that you can see the output as long as you want. So I write getch again, I save the program, Alt F9, I compile the program, and now I run the program. Do you see the output now? Well, yes. So the purpose of getch is to hold the output screen. When you press the enter key, then only the output will disappear. Now let's try to understand the purpose of CLR SCR. So for that I remove CLR SCR from here. I save the program. I do Alt F9 to compile the program, and I'll press on Control F9 to execute the program. Now, if you pay a little attention, you will realize that you see the output twice. The first output which you see over here, welcome to C, begin with C, is actually the output of the first program. I mean the output of the first execution. And then the second, welcome to C, begin with C, is the output of the current execution. So what happens is, if you do not write CLR SCR, the output screen will not be cleared of the previous output, and that is why you will always see the outputs of the previous executions. Now what I'll do is I will add CLR SCR again. So over here I'll add it again, CLR SCR, and when I do that, save, compile, execute, and here again you see the output properly. So I guess you understood the meaning of writing. I hope you understood the purpose of writing CLR SCR and getch. You should write conio.h only when you write CLR SCR. It is a supporting statement for CLR SCR. Now one thing which you should understand very clearly is that these three statements, getch, CLR SCR and conio.h, should not be written in exam when you are writing a program on a piece of paper. These three statements just help you to see the output properly. So no need of writing these three statements in your theory exam. Now once all this is discussed, let's discuss a little more. Let's go into some details which could be a little difficult. What happens is that when you install Turbo C++ on your computer, a total of 5 softwares are installed as a part of Turbo C++, and that is why we call it Turbo C++ IDE, where IDE stands for Integrated Development Environment. The first software which works on your program is the text editor. This blue screen which you see in front of you is the inbuilt text editor of Turbo C++. Text editor is a program which will help you to edit text like Notepad. So Turbo C++ has its own text editor, and using this text editor you can type, cut, paste, copy, save text. Now once the text is saved, once the program is saved, you go to compile and you press this compile again, or you can press Alt F9. Sorry. Now when you compile the program, actually 2 softwares work on your program. The first software is called Preprocessor and the second is called Compiler. Well, you know very well what the compiler does, so let's talk about Preprocessor. Preprocessor is a software which will do the work of substitution, and a preprocessor comes into action for Preprocessor Directive. Hope you remember that any statement starting with hash is called Preprocessor Directive. Now I will explain you why exactly did we write hash include stdio.h. To understand this, let's go to the TC folder. So this is TC. Inside TC, pay attention, this is one folder called include, and when you go inside include you will see all the files have extension .h. So I hope you have realized that these all are header files like conio.h. Then over here you see stdio.h. Let me just click stdio.h and you will realize there are some contents inside the file stdio.h. Now we are not bothered about what contents are there inside this file. We just need to understand one thing. We need to understand why exactly we wrote hash include stdio.h. What happens is that the preprocessor will substitute this entire statement by the contents of stdio.h. Yes, you heard it right. Whatever you saw in the file stdio.h, all these contents will be substituted in place of this statement. Similarly, whatever contents are there in conio.h, these contents will be substituted in place of this statement. So, if you ask me in one word what work preprocessor does, I will say it is substitution. Now, why this substitution is done, that we'll see exactly in chapter number 6, functions. Okay, so you understood what a preprocessor is. After preprocessor, the compiler comes into action. You all know that the compiler will first check the program for errors. If there are no errors in the program, it will convert the program into machine language and will store it inside a file with extension .obj. Remember, you saw a file first.obj. Then you click on run, or you can also press Ctrl F9. When you press Ctrl F9, two softwares will work on your program. First software is called linker and another is loader. Now this is a very small program, so linker has no real role to play over here. So let's not talk about the linker. Let's talk about a loader. If you remember, you had saved your program in C:\tcbin. Let me show that to you again. So this is C:\tcbin, and over here you had saved your program. So please understand one thing, you had saved your program inside the hard disk. Now what the loader will do is, as its name tells you, it will load the program from hard disk to RAM, and then it will start the execution of the program. Your program is copied from hard disk to RAM, and then the execution of the program starts. So to summarize it all, we will say that the following 5 softwares will work on your C program. The first one, text editor, then preprocessor, then compiler, then linker, and finally loader. So that was how we do C programming.
Hi everybody, I am Sandeep Gupta and this is the second part of lecture number 2 of C programming series. In this second part, we'll be studying algorithm and flowchart. Now what exactly an algorithm is? An algorithm is an English-like representation of the program. So when you write the steps of the program in English language, it is called an algorithm. In order to understand this definition better, let's go through a PowerPoint presentation.
To understand the definition of the algorithm, let's consider this program. Write a program to display maximum of 2 given unequal numbers. So this will be a C program in which the user will give 2 unequal numbers to the program, and the program in return will display the maximum of these 2 unequal numbers. If the user enters 5, 6 on the keyboard, then the program will display 6. Now, if I want to do a C program, I'll first write hash include stdio.h followed by void main and opening brace. Then I will write a statement int a comma b. Right now my aim is not to explain you the syntax of the C programming language in detail. We will understand the syntax in detail in subsequent chapters. Right now my aim is to explain you the definition of an algorithm. So just understand one thing. In this statement, a and b are 2 variables, the way we have variables in algebra, and int over here means that they can store integers. A and b can store integers. Now let's go to the next statement. You all know that this statement will display enter 2 unequal numbers on the monitor. Now just try to imagine this. On the black screen you see enter 2 unequal numbers. So obviously the user will type 2 numbers, Let's say the user types 5 and then 6. To read 5 and 6, we will write a scanf statement. Again, right now, I am not going to explain you what is this %d, ampersand, all these things. Let's not focus on the syntax. Just understand one thing, that the first number will be assigned to A and the second number will be given to B. So if the user has typed 5 and 6, 5 will be given to A, 6 will be given to B. The next statement is self-explanatory. It says if A greater than B, printf A. You all know printf does the work of displaying. Also note the fact that this A is not inside double quotes. Because A is not inside double quotes, the compiler will display the value of A if A is greater than B. If A greater than B is false, that means if B is greater than A, so for that we will write else, and under else we will write printf B. So if A greater than B, display A, else display B. So that gives us the program to display the maximum of two given unequal numbers in C. Now this was the C program. Let's do one thing. Let's write the same program in C++. Why we are doing that? We'll come to know in a minute. If you want to write the program in C++, then the first statement will be different. So we'll write hash include iostream.h instead of stdio.h. Void main will remain same. Int a comma b will remain same. Instead of printf, we will write cout, enter two unequal numbers. Instead of scanf, we will write cin ab. So again, over here we'll write a cout. Over here we'll write a cout. Now on the screen, what you see in black color is a program in C language. What you see in red color is a program in C++. Both the programs will do the same work. They will display the maximum of two given unequal numbers. Now let's try and write the same program in English language. Yeah, you heard it right, in English language. If I want to write this program in English language, so for all the statements starting from here till here, I repeat, for everything starting from here till here, I will just write one step, and that is step number 1, start. So start is for everything till here. Now we'll write step number 2 for printf and scanf. So just ask yourself, printf and scanf together do what work? So I will say together printf and scanf read two unequal numbers from the user, and these two unequal numbers are then assigned to A and B. So I'll write step number 2. Read two unequal numbers as A and B. So this step number 2 is for printf as well as scanf. Now steps 3, 4, 5, 6 are self-explanatory. So this is step number 3. It says if A is greater than B, go to step 4, else go to step 5. Can you take a guess? What are you going to see in step number 4? So in step number 4, we will write display A and then go to step 6. In step number 5, we'll write display B and then go to step 6. And step 6 is obviously stop. If you don't write go to step 6 over here, then after display A, we will come to display B, and B will also be displayed, which we don't want. We should display either A or we should display B. Go to step 6 over here is optional, because after step number 5, anyway, we are going to execute step number 6. Anyway, coming to the point. Now what you see in the blue color over here is the same program written in English language. So once again, on this screen you see actually 3 programs. All the programs display the maximum of two given unequal numbers. The black color is the program in C. The red color is the program in red. The red color is the program in C++, and the blue color is the program in English. Well, what you see in blue color is actually not a program, it is an algorithm. An algorithm is an English-like representation of the program. So when you write the steps of the algorithm in English language, in English-like words, that becomes an algorithm. Hope you understood the definition of the algorithm.
Welcome back. Now, let's study one more algorithm. The question over here says, write an algorithm to find sum of first 100 natural numbers. Please keep one thing in mind, that if you ever want to solve an algorithm or a program, the first thing is that you should understand the question properly. So over here, you should know that the first 100 natural numbers are 1, 2, 3, 4 till 100, and you are supposed to write an algorithm which will find the sum 1 plus 2 plus 3 and that way till plus 100. So this is the question. Now you know one thing, that for every algorithm the first step is start and the last step is stop. So that makes it step number 1 and step number 7, start and stop. Now in this algorithm we'll use two variables, sum and I, and we will initialize variable sum to 0 and variable I to 1. Either you can write the word make over here or you can write the word initialize, either way it's fine. One more small thing, what some teachers do is, instead of writing sum equal to 0, they may write something like this. They may write sum arrow 0. So that is also fine. Different terminologies of writing the same thing. Whether you write equal to or arrow, it is okay. Anyway, moving further, you may have one question in your mind. Why am I initializing variable sum to 0 and variable I to 1? So I'll answer that question when we reach the end of the algorithm. Now moving further, step number 3 I'll write very shortly, but before that step number 4 would be compute sum equal to sum plus I, compute I equal to I plus 1. Now we are supposed to find the sum of first 100 natural numbers. So over here step number 3 will be execute steps 3 and 4 100 times. Execute steps 3 and 4. I'm sorry, it's not 3 and 4, it's 4 and 5. So execute steps 4 and 500 times. Now let's do one thing. Let's try to understand the logic of this algorithm with the help of a table. So over here what I'll do is, I will draw a table of variable I versus variable sum, and you know that variable sum is already initialized to 0. Now to keep things small and simple, we'll do one thing. Let's assume, let's say we want to find the sum of first 3 natural numbers. If you want to find the sum of first 3 natural numbers, then one simple change in this algorithm would be, instead of writing 100 over here, we will write 3 over here. So we'll execute steps 4 and 5 3 times and not 100 times. So now let's see how this logic works. Let's start. Sum is equal to 0. Step number 2, sum is equal to 0 and I is equal to 1. Execute steps 4 and 5 3 times. So now let's do the first execution. The first execution says compute sum equal to sum plus I. Now when we write a statement like this sum is the new sum and this is the old sum. So the old sum is 0, I is 1. So the new sum is equal to old sum 0 plus 1 is equal to 1. Similarly, I is equal to I plus 1. this is the new I, this is the old I. So the new I is equal to the old I, which is 1 plus 1. So the value of I is now 2. Now, how many times did we execute these two statements till now? Only once. This once, this once. So now, let's execute both the statements second time. Second time. So second time. Sum equal to sum plus I. Take 2 seconds. Calculate in your mind what it would be. So sum is equal to old sum 1 plus I 2, which is equal to 3. I is equal to old I 2 plus 1 is equal to 3. So, 2 executions of steps 4 and 5 are over. Now, let's execute them third time. So, third time, a little fast, sum is equal to old sum, that is 3 plus I, that is 3, which is equal to 6. I is equal to I plus 1, that is 4. Now, after we execute these statements 3 times, have a close look at the value of sum. If you see over here carefully, you will realize sum is now equal to 6 and 6 is the sum of the first 3 natural numbers. So, if we execute these two statements 3 times, we get the sum of first 3 natural numbers. So, if you want the sum of first 100 natural numbers, you should execute them 100 times and then we should go to step 6. Can you take a guess what will we write in step number 6? So step number 6 would be display sum. So that completes this algorithm. Now, although this algorithm is correct, but still this is not the best algorithm which we should be writing. Now, why that way? So the first thing which I want to tell you is that when you do programming, when you write a C program, you will never write step number 3 this way. You will write step number 3 in some other way. Now, why that way? So first understand one thing. See over here, step number 3, 4, 5 together constitute a loop. I repeat, step number 3, 4, 5 together constitute a loop. Now, what is the meaning of loop? A loop is a structure, a loop is a program structure which executes repeatedly. So, in a program, if you have some statements which execute again and again multiple times, that is called a loop. So, over here, steps 4 and 5 are executing again and again, and steps 4 and 5 is controlled by step number 3. So 3, 4, 5 together constitute a loop. Now what I was saying is, a better way of writing step number 3 is this. What you can do is, instead of writing this, you may write, let me erase this, and now you may write, if I less than equal to 100, then execute steps 4 and 5, else go to step 6. And over here I will add one statement, go to step 3. In case you can't see this properly, this is 3. Go to step 3. So now that completes the loop effect. Now, this I less than equal to 100 is a condition which could be either true or false. When we write this condition, we are basically asking a question whether I is less than or equal to 100. If it is true, steps 4, 5 will execute, and if it is false, then they won't execute. Okay. So now what we'll do once again, we'll try to understand this logic with the help of the same table. And again, to keep things simple, smaller, instead of writing 100 over here, we'll consider this to be 3. Okay. Now, I'll erase the table quickly so that we can start again. Okay, let's start again. Sum is equal to 0, I is equal to 1. We come to step number 3. A question is being asked over here. Is I less than equal to 3? In other words, is 1 lesser than or equal to 3? The answer is true. Because the answer is true, we execute steps 4 and 5. Now you know how step 4 and 5 work, so that I need not explain. So 4 would be this, sum equal to old sum plus I equal to new sum, and I will be 1 plus 1 equal to 2. I'm sorry, I made a small mistake over here. This go to step 3 should have been over here. This go to step 3 should have been over here. Sorry for that. So now I is equal to 2, and over there I have written go to step 3. Now go to step 3 means we'll come back over here and again the condition executes. So again we'll check whether I is less than equal to 3. So 2 less than equal to 3 is true. Again steps 4 and 5 will execute. So step number 4, sum is equal to old sum, that is 1 plus I, that is 2, which is equal to 3. I is equal to I plus 1, that is 3. Go to step 3, you come over here. Again checking is done, again the condition checking is done. Is 3 less than or equal to 3? The condition is true. Again step number 4 and 5 will execute. So sum is equal to old sum 3 plus I, which is equal to 6. I is equal to I plus 1, that is 4. Now pay attention. Go to step 3 will bring you over here. What is the value of I now? 4. Is 4 less than equal to 3? The answer is false. The condition is false, and the execution of step 4 and 5 will stop over here. So now I will say the loop stops over here and will now go to step 6, which will display the sum. So this is an alternative to the earlier algorithm. One question pending. Some of you may have a doubt in your mind, why have we initialized sum to 0? So please understand one thing, in programming, whenever we find sum of something, we always initialize sum to 0. Because you may know one thing very well, that anything added to 0 remains same. The next question is that why have we initialized I to 1? So the answer is very simple. We were supposed to find the sum of all the natural numbers. Natural numbers start with 1, and that is why I was initialized to 1. So this was the algorithm to find the sum of first 100 natural numbers. Now let's study a variation of the previous algorithm in which the question is, write an algorithm to find sum of first n natural numbers. So if this is the question, then you are required to find 1 plus 2 plus 3 and that way till n. Now we just need to do some small changes over here and that will give us the new algorithm. So let's understand what the changes will be. The first thing is, If we are told to find the sum of first n natural numbers, then we need to ask the user for the value of n. So over here, step number 3 would become read n from user. I repeat, read n from user. Now once we have finished reading n from the user, a simple change will finish the algorithm. Instead of writing I less than equal to 100, we'll write over here if I less than equal to n. And that's it. We just need to change the step numbers over here, increase the step numbers by 1. So this will be 4, 5, 6, 7, 8. And then don't forget to change the step numbers here too. So this will become steps 5 and 6, 5 and 6, and this will become step number 7. So that gives you the algorithm to find the sum of first n natural numbers. Now that you know what is an algorithm, we are ready to study a flowchart. Now what exactly a flowchart is? A flowchart is a pictorial representation of a program. In other words, it is a graphical representation of the steps of the algorithm. What we do in flowchart is we use various shapes to depict different operations. So now let's study what those shapes are. Now let's study the various shapes which are used in the flowchart. The first thing which we'll use in the flowchart is the start and the stop. Start and stop in a flowchart is always given inside a flat oval. So if you want to show start stop, then within a flat oval you write either start or you write stop. A flat oval is sometimes also called rounded rectangle. I'm not very good in drawing shapes, so please excuse my drawing, but this is a flat oval, although it does not look like one, or also called a rounded rectangle. Now, one very important thing which you should know over here is, instead of writing start over here, it is correct if you write begin. Instead of writing stop, it is okay if you write end. So what you write inside that flat oval does not matter so much. What matters is the shape. So if you ever want to depict start or stop, you have to do it inside a flat oval. The next thing which we use in a flowchart is input output. Input output is always shown inside a parallelogram. Take a few seconds and tell me which step in this algorithm is input and which is output. Step number 3 is input, where we are reading from the user, and step number 7 is output, where we are displaying something to the user. So whenever you want to read or display something in a flowchart, it is always done inside parallelogram. So inside a parallelogram, you may write something like read n. Inside the parallelogram, you may write something like display sum. Now again the same thing over here. Instead of writing read, it is okay if you write input. Instead of writing display, it is okay if you write show. But again, what matters is the shape parallelogram. So input output is parallelogram in a flowchart. The next thing is called process. A process is depicted using a rectangle. Now what exactly a process is? Very simple. Any initialization or any computation is called process. So it is quite obvious that we are doing initialization in step 2 and computation in step 5 and 6. So if you want to depict a process in a flowchart, you will write something like this. I equal to 1. You need not write the word initialize. Similarly, over here you may write sum equal to sum plus I. You need not write the word compute, that's understood. The next thing which we often use in a flowchart is called decision. decision is nothing but a condition which can be true or false. I am sure you all know that step number 4 over here takes a decision. Now, in this step number 4, we have a condition I less than equal to n. So, if I want to show that over here, I will write is I less than equal to n question mark. Now, whenever a question is asked, there are two answers, true or false. So, from here, I will take out one branch which will correspond to true and another branch which will correspond to false. So, that's how a decision is depicted in a flowchart. Finally, in a flowchart, we use a path. A path is nothing but an arrow which will be used to connect two or more symbols of the flowchart. So these are some of the most frequently used symbols of the flowchart which we studied with the help of this algorithm. Now that you know the basic shapes of a flowchart, we are ready to solve a problem. So this is the problem. Draw a flowchart to find maximum of two given unequal numbers. Hope you remember that we have already done an algorithm for the same problem. So let's convert the steps of the algorithm into a flowchart. Now step number 1 over here is start, which is given inside a flat oval. So I will draw a flat oval over here, that is rounded rectangle, inside which I'll write start. Now have a look at step number 2. In flowchart terminology, can you give me one word for step number 2? Yes, that would be input. And input is always given inside a parallelogram. So now I will draw a parallelogram, and inside the parallelogram I can write the same thing which is written over there. So I write read two unequal numbers, as A and B. To connect these two symbols, now I will draw an arrow. So the arrow connects these two symbols. Now look at step number 3. In flowchart terminology, that step number 3 is called decision. And for a decision, we are supposed to draw a rhombus, a diamond. So now I will draw a diamond, a rhombus, and inside the diamond, inside the rhombus, I will write is A greater than B question mark. Now whenever a question is being asked, there are two answers, yes, no, true, false. So over here, you will be having two exit points, one corresponding to true and another corresponding to false. Now, if the condition is true, we are supposed to execute step number 4, display A. If the condition is false, step number 5, display B. I hope you know display is basically output, and output is given inside a parallelogram. So now again I will draw a parallelogram over here, inside which we will write display A. One more parallelogram over here, inside which we will write display B. Now take a note of the fact, after display A, we are supposed to go to step number 6, which is stop. And after display B, naturally the next step is 6, which is stop. So now I will write stop over here inside a flat oval, and we will come to this stop either from display A or from display B. So that completes the flow chart to find maximum of two given unequal numbers. To understand flowchart better, let's solve a problem. Draw a flowchart to find sum of first n natural numbers. I hope you remember we have already done this algorithm. So all we now need to do is convert the steps of the algorithm into a flowchart. Now step number 1 over here is start. You know start is always given inside a flat oval. So inside a flat oval I will write start. Step number 2 says make sum equal to 0 and I equal to 1. Hope you remember this is initialization, which is called process in a flowchart, and it is given inside a rectangle. So inside a rectangle I will write sum equal to 0 and I equal to 1. Either you can draw two rectangles over here, or you can write both the statements into a single rectangle. Either way, it's fine. To connect the two shapes over here, I will now draw an arrow. This arrow is called a path. Now, can you give me one word for step number 3? Step number 3 is input, which you know is done inside a parallelogram. So, inside a parallelogram, I will write read n from the user. So, read n from the user. And again, I draw a path over here. Step number 4 is a decision which is given inside a rhombus, also called a diamond. So, now I will draw a path and then a decision box, a diamond, and inside that I will write is I less than equal to n question mark. If this condition is true, we are supposed to execute step number 5 and 6. So I will label this path as true. I will label this path as true. And over here, I will write step number 5, that is sum equal to sum plus I, and step number 6, I equal to I plus 1. Now, hope you remember that step 4, 5 and 6 together constitute a loop. And to complete the loop effect over here, we will write go to step 4. Go to step 4. Now, how do we complete this loop effect in a flowchart? How do we write this go to in a flowchart? Very simple. We just need to take help of the path of the arrow. So, we take this arrow here and we take it back to step number 4. So, we take it back over here to the decision. So, that completes our loop. If you look at this a little closely, you will realize it is nothing but a loop. So, now this loop will execute again and again as long as the condition I less than equal to n is true. Now, what if the condition is false? If the condition is false, look at the algorithm and tell me which step number are we supposed to execute. Step number 7, display sum. So, by now you know it must be given inside a parallelogram. So, inside a parallelogram, I will write display sum. And finally, step number 8, stop, which should be given inside a flat oval. Let me try and draw the oval nicely this time. No, I think I have not drawn it again properly. Anyway, so that is the flat oval. So that gives you the flowchart to find sum of first n natural numbers.